Hello. Today, I want to show you a little bit about how to do a problem to be able to calculate such things as kinetic energy from potential energy. So, we're looking at this person right here. There's a skateboarder. He's 10 meters up on a big hill, and he's going to skateboard down that hill, and we're going to assume that he has no friction. And my question is, how much kinetic energy will he have when he gets to this point right here um, at point C? And we're on the way there to figure that out. We're going to look at point B and point A. And I guess we'll call this point D at the start here, even though that's a little bit backwards. All right, so how do we do this? Well, the only way we can figure out all these energies, different energies here, is if we think of the law of conservation of energy and draw some pie charts. So I'm going to first draw a pie chart for this person at point D. And we know that since he's at the top of the hill, he will have gravitational potential energy. His pie chart will have gravitational potential energy. And I'm assuming he's not moving at all at the start of the hill or at the top of the hill. So he's up high, so he has gravitational potential energy. At point A, he's at the bottom, so he can't have any gravitational potential energy there. So what is his energy then? We know from the law of conservation of energy that before must equal after. And this is after at point A. So where's the energy? What's the energy? Well, the energy is stored in his motion. It's stored in something called kinetic energy. So there I've written kinetic energy. And how about at point B? What kind of energy or how is his energy stored there? Well, if we look at this, at point B, he's 5 meters up. At the top of this hill, he's going to be 5 meters up. And he started 10 meters up. And you know that gravitational potential energy depends on how high you are. In fact, right here, he's half as high as he was at point D. So you should be able to draw a pie chart and find out how much energy he actually has at point B, or what how it's being stored. And he's got half as much gravitational potential energy as he had at the start. So I'm going to write half the pie as gravitational potential energy. Well, what's the other half of the pie? Well, when he went up this hill, he didn't slow down completely here because he had enough energy to get all the way back to the top if there's no friction in his skateboard. All right, if his skateboard is running perfectly well, then he's going to be able to get all the way back to the top of that hill, but he's not going all the way back to the top of the hill. So he must have some leftover speed. So he's storing kinetic energy. And then finally, how about at point C? How much energy will he have there? Well, he's got only 2.2 meters of height there. So that's not going to be a lot of gravitational potential energy. I'm going to just make an estimate that's a little bit less than quarter of his pi is going to be gravitational potential energy, and the rest will be kinetic energy. He's going to be going pretty fast still at point C. All right. So now I'm going to go ahead and I'm going to actually figure out how much gravitational potential energy this person has. And I didn't tell you this at the start, but this skateboarder happens to have a mass of 60 kilograms. Okay. So we can write that the gravitational potential energy equals mass times gravity times height equals 60 kilograms times 10 meters per second times his height, which is 10 meters. And if we do all that math, we get 6,000 Newton meters. And that's his gravitational potential energy at the start. I'm going to stop this video and then I'm going to make another video to show you the remainder of the energies that we can calculate.